Right, on to some more interesting stuff. Servo our installation. We're now on page 24, which is bag 15, and we've got two bags here. One with the aileron servo mount and canopy mounts, and the other with various mounting plates and bolts for the tail and throttle servos. Looking at the left-hand side of the heli, fairly conventional setup. We've got a front-mounted rudder servo, keep it out of all the gunk from the exhaust, and we've got a throttle servo down here. That's a full-size cutout. We could, of course, use a smaller plate in there and a MIDI-size servo like a 9257 if we had a hankering to. But I'm going to put an Align 620 in there because I like them. I'm going to use a BLS 251 in there, and I'm going to use Align 610s on the Cyclic. This is the contents of bag 15.1. There's 4 carbon mounting plates. There's 8 2.5 by 12 mounting bolts there. And then we've got 4 of each JR and Futaba 2.5mm diameter holes, which are just the right size to take the thread and be screwed in, and 3mm holes, which basically freely take the bolt, and this can be used as a spacer. They look very similar, and the only measurement difference I could find is there's 0.5 millimeter difference in the spacing of the servo holes, but other than that, they're exactly the same thickness as each other. I'm going to be using the Futaba one, the Align ones, so they go with the generally with Futaba fittings. So I'll use these Futaba plates. This is our rudder servo, output shaft towards the back, and we've got our M2.5 bolts going through the carbon plate, going through the rubber grommets. There's inset ferrules in there, and we've just pushed in one of the nuts, the 2.5 nuts, into the holes, and we're going to screw that down directly into that. There isn't any room for the spacer, the 3mm spacers, so I'm hoping that the geometry will be about right. Otherwise, we're going to have to get some longer bolts. That's our throttle and rudder servo mounted up. That wasn't too difficult. Put the bottom one in first, and you can get at the plates from behind. I didn't use any spacers there. I think the throttle servo is going to be okay. We'll put balls on the outside of the output shaft here and on the inside of the arm there, and then we'll just have to see how we go with the rudder one, but no spacers on these two. Just before we mount up the front Cyclic servos, it's a good opportunity now to go over the edges of the carbon frames. Next up, we mount our Cyclic servo mounts. That seems to be the same both ways up. That just slides in from the front here. There's 2 locating holes. The back one's got an M3 by 8mm bolt in it. The front one is secured by a short M3 nylon thread, which goes into the thread from the front into the thread into the block, and then with that protruding from the side, we can then screw our servo mount on top of that, all Loctited. There's our mount in place, secured by the M3 bolts, and we'll just wait for the Loctite to set on these studs into the alloy mount before we screw down the canopy mounts with the rubber on. Right, on to some of this exciting looking servo mounting software. First off, we're going to open up bag 16.1 for the Cyclic servo mount, which we can mount on the frame that we just put into the carbon sides. This is the contents of bag 16.1. We've got our servo mount here. This is going to be mounted onto the frame by 3 M3 bolts running through rubber dampers with aluminium formers at the end. That's a common theme throughout the Kasama stuff. The servos have got M2.5 bolts as previously, with servo mounting plates there, carbon fibre ones, and we've got some of the nuts, the 2.5mm nuts to screw the bolts into in bag 16.2, which has also got the output shafts on here. And I'm not sure we're going to need any spacers here. I'm going to put them together without first of all and see how we go. The flat side of the mounting plate is the surface that we mount our servos onto, and the recessed and machine bits are facing towards the rear of the helicopter. The plastic bushers are pushed through the holes in the mounting frame, and then you can push in the aluminium grommets from the front and the back. In bag 16.3 we've got two sets of mounting hardware for Futaba or JR. The Futaba output arms are the blue, the JR ones are the red ones, and there's bushers for the grommets in the servo, and there's also mounting nut hardware there as well. So we'll get the blue ones out to go with our Align 610 servos, and we'll mount those up onto the servo frame there. Here's the servos mounted up in their nice mounting bracket, going M2.5 bolt, carbon spacer, grommets. I didn't use Kasama's aluminium bushers. They didn't go down the grommet very well, so I used the grommets that came with the ferrules that came with the Align servos. Through the aluminium plate into the nuts below, and there's also a carbon fibre spacer just down there. Now we have to put the servo arms on. They go lined up basically in line. Very useful to have a servo tester handy, so you can centre up the servos out of the heady without having to muck around getting the radio set up. So that's our centre on there. Looks like that's going to be the closest we're going to get it that way around. Just turn it upside down, see if there's any difference in the machining, and that's not far off being aligned down there. That's pretty good. So that just shows that the machining is eccentric. Now these are quite tight on Futaba servos, as are the Quick UK CNC arms. So try and get it right first time, because you're going to have a bit of a devil of a job trying to get these off once you've screwed them down. But having got that aligned up there now, we'll now put in the screw that comes with the servo to draw that down onto the output shaft. And there's the CNC arm drawn down with the screw, the output shaft screw, and a little dab of Loctite, blue Loctite on the end. And we'll do the same for the other one now. There's our second servo set to mid-stick, 1500 microseconds, being a wideband servo. And again, you can see this is an even better fit this time. The output shaft basically lines up almost exactly in line, which is how we want it. Now we put the servo horns on, we can make up the output shafts from the servos with these natty little metal flexible coupling rings. These are all the bits out of bag 16.3. These discs, flexible couplings, I think are the most fascinating thing out of the whole helicopter. 3 of them go together basically, and this forms a torque strong means of transmitting force between the two couplings, and yet it retains some flexibility for any bending in the shaft. Very nice idea. And these are secured, 3 of them thick, by short little M2x4 bolts that go into the output horn and the output couplers down there. So first off, we'll put 3 of these together, mount them onto each one of these couplers, and then later on we'll mate up the drive shafts and the lever arms down here with the ball joints. Now we can assemble the torque shafts. First of all, put the ball links in the lever arms. These go in from the same size as the protrusion on the arm, and they're secured in place on the shaft by these M4 set screws, and these go into the end of the shaft with the recess near the end. The recess that's set back a little bit from the end is where these coupling discs go, and that's to allow the end of the shaft to come through and go into the bearing block that we previously mounted up on the top bearing block. So we'll put these together now and assemble it up. And there's our output shafts made up. Obviously we don't want to Loctite or do up the set screws, we just have them gently down up so we can do final adjustments when we mount these up onto the helicopter. We can then attach these now to the output horns using the remaining 4 M2 screws, and then we'll be ready to mount this up on the helicopter. Little tip is place the remaining 2 bolts in when you're doing up 2 of these threads, just to preserve the orientation of the holes if they get out of kilter, when you tighten them up, the thing's going to start buckling. So sometimes they're not, they get a little bit out of sync, these holes. So that's just something to watch. Once they're attached, you can see how they're torsionally rigid, but they're flexible in 2 dimensions. So I think that's really clever. We can now mount that up onto the helicopter using the 3 M3 by 20 bolts through these mountings, and these fit into the 2 mountings that we've just on the mount that we put on before, and also into the governor mount down there. So we'll offer those up there now and make sure the front of the shafts go into these flange bearings on the back of this carbon plate. Once the servos are mounted up and secured with the 3 bolts, you can tighten up the set screw on the servo coupler down here, making sure you find the recess, of course, in the shaft. And then you can slide up this latter control arm here. You're supposed to leave 0.5 millimeters of clearance between the control arm and the flange bearing, so I thought just a bit of card down there would do that. Push it up against it, do up the set screw, and that should be our 0.5 millimeter clearance between the end of the arm and the flange bearing. Once you're satisfied with that, do that nice and snug. And there we are, that's one arm done. And then we can do the same on the other side down here. And that's our servo in action there. It's pretty cool. And if we center our servo at 1500 microseconds there, have a look there. I'd say that's pretty well spot on square, so we're not going to need much sub trim adjusting that center for dead stick. So very nice, probably one of the most distinctive features of the heli, I'd say. On to bag 17, and it's a similar setup but customized for the elevator servo. The elevators are mounted on 2 standoffs, either Futaba in the blue or JR in the red. It has an output lever and an output shaft and the disc couplings as before. And the standoffs basically go on the right hand frame, and they go into these 2 holes down here, one just by the clutch and one just behind the front canopy standoff down there. So these are secured by M3 by 6mm bolts that will mount our 3rd Cyclic servo onto the servo mounts, the standoffs which go on the holes we illustrated. I've decided to mount the servo onto these and do the assembly because it'll be a bit easier once it's mounted onto the helicopter. This time there's no carbon plate standoffs, just 4 M3 by 10mm bolts that go through the normal grommets and brass ferrules as we find on the servo. So we'll get that together now. That's our elevator servo mounted up onto the standoffs. There are M3 bolts supplied. The normal ferrules that go down through the grommets don't take M3, and I didn't have any suitable, so I put some carbon plates on and just put them down neat through the grommets and Loctited them into the standoff, and I think that'll do. And note how on this one the output shaft is on the lower side of the servo in contrast to the Cyclic servos. And there's our servo set up at centre stick, 1500 microseconds, and you can see again we've got the horn going down absolutely dead centre down the servo, which is very pleasing. There's our coupling plates all assembled there now on the servo with our shaft ready to go. Again, the offset basically goes backwards because that's going to go into the idler bearing. We put our ball link on our control arm here, and this is facing this time away from the hub of the control link. And we're ready now to mount this up with our 2 M3 by 6mm bolts. You'll be pleased to hear that there's plenty of room. There are recesses made on the other side of the frame so we can get our nut driver in there, no problem. Nora's busy building as well. She's got her own build problem. She's got a big bit of cloth there and she can't get it in the box. I don't know what she's going to do. There's one frustrated rat. This is our elevator servo mounted on its two aluminium blocks. Then our flexible coupling going into our control shaft. This time the control shaft goes through the bearing block, and the bearing's mounted on the outside, and I put a 0.5 mm clearance there as well. Loctite up these set screws. That's the servo at mid stick, and again, look at that, beautifully perpendicular. Last thing to do now is to make up the control rod that goes between the output to the torque shaft to this bell crank up here, which is to then get linked to the swash plate. And to do this, we've got a very natty little item down here. This might not look much, but this control rod has a couple of unusual features. One is it's very light, and for 3 mm. It's obviously not steel, this is titanium. Secondly, it's got a little square machined onto it, and then we've got this natty little turnbuckle wrench there that we can then use to do it up. At least we could if it fitted on there. Look at that, isn't that absolutely beautiful? I wish we could get all of our control rods like that. Ball links on the end, these are very substantial. They look like they might be unidirectional. There's just a bit of a this looks fairly closed in, and looks like there's a bit of a lip on that side, so I'd say these are unidirectional, so watch which side you put them on, and basically, as per manual, make the link up to 63 mm between ball links using the turnbuckle wrench. Now, one little gotcha about this innocuous looking thing is that it's having a lot of trouble screwing on the other end of the ball link. And what I found is that this has got a right-hand thread on one end, and this has got a left-hand link on the other. So this is just like a turnbuckle, and you can use your little spanner once it's on there for actually adjusting it, and it will be screwing in or screwing out of both ball links at the same time. So a very neat little catch there, but there's absolutely no mention of it in the manual. So anyway, we set our length to 63 mm and stick it onto the ball crank lever, and once it's installed, and these were very tight to push over the ball links, but once they're on you can see how easy they move, so these are very well engineered. But once that's on, we can use our ball crank, our turnbuckle there, and we can screw this down until we get our bell length lever here exactly perpendicular. You can see that the bell crank output from the servo is at right angles. This isn't quite square yet, so we'll just carry it on. This is exciting. I've never done anything like this before on a model heli. On the stays of a boat, of a sailing boat, that's another thing. And we've just popped the ball off there. Sneak that back on again. Make sure it's on the right way around. And click. Okay, well, I think we're just about run out of adjustment, which is just as well, because I think we're just about square on there now. So another very, very neat little feature. Okay, well, that's enough for tonight. Tomorrow we'll put the swash plate on and we'll start up the mast, putting on the washout arms, centre hub, seesaw, and see if we can get up to the rotor blades. So have fun.